Let's look at another example here. All right, again, just a little bit more interpretation with those graphs of normal distributions. So this is an example of math test scores. So this is the scaled test scores for the New York State Grade 4 Common Core Mathematics test are normally distributed. So when you see normally distributed, you're going to see that nice bell-shaped curve. So the normal curve shown below represents this distribution. And we want to know what is the mean test score and also what is the standard deviation. So this is an example where you're given the graph and you have to find the information. So kind of working backwards here. So remember, your mean is always at that center. So we're looking at that center line here to find the mean. And I actually printed the solution here as well because it's much better than my drawing. But you can see here, we have this center line kind of coming right down here. And that is always your mean. Now you have to estimate the values. If you look at your tick marks, and again, the picture in the book's a bit clearer, the tick marks are going by tens. So this right here is 280. This one is 290. This one is 300. This one is 310, 320, and so on. So that mean is right in the middle of 300 and 310. So our mean looks like it's about 305. Now, for your standard deviation, you want to use that idea of the inflection points. So if you look at your curve here, you want to see, okay, where does it change from concave up to concave down? So where does that U flip? And it flips right around here. And same thing on the way down on this side. You can see that it's down here, and then it eventually flips to be up. So where does it flip? It flips right there. And the point at which it flips at is always the mean minus 1 standard deviation and the mean plus 1 standard deviation, always. So if I can figure out these values, then I can figure out my standard deviation. Now again, I know this picture is not really great to see. This here is 270. This would be 260. So it looks like this point here is right in between 260 and 270. So it looks like it's about 265. And then on this end, we have, this is 320, 330, this is 340, and then this one is 350. So again, it's right in between. So it looks like it's at about 345. So we're just estimating here. Now, that 345 and that 265 is the mean, either plus or minus the standard deviation. So what I can do is I can take that 305 for my mean, subtract with, or we'll go this way, right? Subtract with 345, and I can get the change. So that change here is going to be the standard deviation. And we can do the same thing with this number here. So if I try the 305 is my mean, and I'm subtracting with the 265. I'm just subtracting to make my number positive. And I get 40 again. So again, that change is going to be your standard deviation. So the inflection points represent the mean plus 1 standard deviation and the mean minus 1 standard deviation. So if I can find those values, and I know the value for the mean, then I can subtract to find the change, and that change is going to be our standard deviation here. So our standard deviation is about 40, right? And again, really both of these are approximate because we're just using the graph to estimate, but that's how we could find our standard deviation from the graph. Okay, now just a little bit more. So if you think back to the empirical rule back in section 2.4, where we were looking at all those percentages for that bell-shaped curve, we do know that about 68% of the scores are within 1 standard deviation, right? So 68% is from the mean minus 1 standard deviation to the mean plus 1 standard deviation. So our values there were 265 to 345. So about 68% of students got scores between 265 and 345. If we want to go further with this, we can. So you want to remember that about 95% of our data is between 2 standard deviations Now, I don't have these values yet, but I can find them, right? So if my mean is 305, and I want to subtract 2 standard deviations, or add 2 standard deviations, I can just multiply that 40 by 2 and do my adding or my subtracting. So that's how we're going to get that 225, and then that 385. And then finally, the last cutoff we had from the empirical rule was 99.7%, and that was always within 3 standard deviations of the mean. So again, I don't have these values here yet, but I can find them. So I know my mean and I know my standard deviation. So what I can just do is do some multiplication with some adding or subtracting and get those final values. And the values I'm going to get here would be 185 to 425. Okay, so almost all students, not quite all, but almost all students, this up a little bit, are scoring, oh sorry, this would be a 5, are scoring between 185 and 425 on the exam. And again, that 95 tends to be our favorite kind of cutoff here, so you can see where the majority of your students are scoring. So we're able to work backwards as well. Take the graph, find that mean, find that standard deviation, and then we can also apply rules that we've already learned to this process as well. So the empirical rule applies here because we're talking about normal curves. So those cutoffs are going to always apply. Now, there is a little tech tip here on the left. So if you want to graph on your calculator, you can. So I'll just show you that quickly. So what you're going to do if you want to graph a normal curve is you're going to hit that y equals button. And we actually have to type in a distribution here. So see how it says DISTR right there? That's for distribution. So we're going to hit the second bars key. And then you're going to see that normal PDF. And then what you do is it's listed here. So you type your x first. That's your variable. Now the second thing you're going to type in is the mean. And then the last thing is the standard deviation. So our mean here was 305 and our standard deviation was 40. And then you're going to hit that graph button. Now, you want to be careful. Notice your mean is at 305. So on your x-axis, you need to be all the way over at 305 to actually see this graph. So I've already scaled it. You can see that my center here is already over at 305. And you're able to just kind of, with the touchscreen, you can kind of pull and see what that curve looks like a little bit easier. Now, I will warn you as well, if you look at my y-axis, these numbers are very, very, very small. So if you initially graph and you're in a standard screen, you're going to see nothing. You're just going to see this like line across your page. So you really need to actually go in and either scroll over or change your window. So here, now I'm seeing 305. But again, I'm not seeing anything because my y-axis is too big. So you have to really, really start zooming in there. I don't need to zoom in that far, I guess. To kind of see the graph start to form and take shape here. So you can see, like, I have to kind of play around a little bit with my scaling so that I can see that normal curve. So the technology is nice, but it's not my favorite, if I'm being honest. I think it's much easier for you to just graph by hand. So if you know what your mean is, and you know it's a normal curve, then your curve is always going to look like this. I know it's not a great picture, but your mean is always going to be at that center. And then your inflection points here are always going to be at the mean minus 1 standard deviation and the mean plus 1 standard deviation. So I think it's pretty quick to graph by hand if you want a visual, but your technology can do it. You just have to watch the window because it's hard to kind of zoom in to find that graph.